ini. Area dengan mamnya, dengan belum. Apa ya? Tuh, nggak mau push. Mau push nggak? Yang mana? Nih. Yang mana? Nih. Kita kan makan pupus aja di depan ini nggak?
기원전 27년
27 years BC, the building called Pantheon Synagogue that has been built by the Emperor Agrippa of Roman Empire is one of the oldest construction buildings that were built during the Roman Empire era. The ceiling roof opening in the Pantheon allows the natural sunshine to come through and the shine the inside of the dome. In order to effectuate the beautiful occurrence, the height of the ceiling has to be elevated 42 meters. One of the main reasons that the ceiling of the Pantheon Synagogue dome ceiling does not have cave-in is because of using special construction material, lightweight aggregate that is lighter than the regular rocks. This time, we'd like to introduce you the principle of the light construction material that can float underwater called lightweight aggregate. There are lots of pores. We can control the density of the lightweight aggregates, and it can be heavy and light as we want. We control the size of the pores inside the aggregates so that it can be served as a construction material that will possess various characteristics. Well, let's take a look at the house and compare the ones built by domestic artificial lightweight aggregates and natural ones. In order to find the difference, we have taken a sample concrete of one made with a natural and one made with the artificial aggregate. The one on the left one is a natural rock. The one on the right is the concrete that are made with the artificial lightweight aggregates. First, we decide to compare the hardness of the two. We put two into press machine and insert the pressure, and as the time passes, both of them started to break apart. Although the result shows the concrete comprised of the regular rock is little harder, the result shows that both can be used in structural construction building. But when it comes to heat insulation, soundproof, and density, artificial lightweight was much superior. If constructed by the artificial lightweight aggregates, because of the pores in the artificial lightweight aggregates, the density of the concrete becomes low. And the pores inside the aggregates decreases the flow of the energy transfer. Because of this, the sound transfer energy and heat transfer energy are lessened. The coal-fired power plant in Yeonghung Island near Seoul, domestic-made ingredients for artificial lightweight aggregates are produced right at this location. In order to generate the electricity when the coal are used, fly ash can be used in part of material for cement, and bottom ash, which now is impossible to recycle and being thrown into the ash pond situated adjacent to the power plant. As of 2009, annually, 8.5 million tons of coal ash has been produced, and out of that, 3.1 million tons is being thrown into ash pond. Waste treatment cost for ash per year comes out to be $50 million per year, but bigger problem is that the lifespan of the ash pond will be dissipated after 3 years. Furthermore, annually the natural aggregates are being procured 200 million cubic tons per year. In April 6, a new factory was erected next to Yeonghung coal-fired power plant. It is the factory that utilizes the coal ash, especially the bottom ash, to make artificial lightweight aggregates. By making artificial lightweight aggregates, it not only enhances the preservation of natural environment and also reduces waste treatment costs, also it creates more jobs. It is like killing 3 birds with 1 stone.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning to honorable speakers, distinguished guests, ladies and gentlemen. For those who join the webinar from Asia, especially in Indonesia, my name is Ken Anne and I'll be your MC and moderator for today's event. On behalf of the Indonesian Electrical Power Society, Masyarakat Ketenagalistrikan Indonesia, MKI, I would like to welcome all of you to the second episodes of the webinar entitled Best Practice for Coal Ash Utilization and Handling, which is organized in cooperation with G-Coal Japan, both Cherai Green Indonesia and Korea, Also PT Tinelo Poliama and sponsored by PT PLN Persero, PT Indonesia Power, PT Pembangkitan Jawa Bali, PT S2P, PT Cirebon Power, and PT Priamanaya. The first episode of the webinar was conducted in April 9, 2021, discussing about optimizing FABA utilization. Invited domestic speakers, coal-ash producers, regulator, academies, and chairman of Indonesian Journalists Association. This episode provides information related to the issue, regulation, and the potential of utilizing coal ash in a mass basis to cope with the current coal ash production. Recently, GOI issued a new regulation number 2022, year 2021, mainly classifying the fly ash and bottom ash, FABA, which were previously categorized as hazardous waste material to become a non-hazardous waste material. These new regulations provides a hope to open a way to utilize FABA for various purposes to support continuous operation of coal power plants, which contributed more than 54% of total energy mix in the country. However, this new regulation still requires a more detailed policy at operational level from the Ministry of the Environment, especially to balance between maintaining the environment and promoting coal ash utilizations. Today's webinar will mainly focus on best practices in utilizing and handling of coal ash from other countries in Asia and expected to give a broad overview and comparison to that of practices currently conducted in the country. Okay, before we get started, I'd like to go over a few items so you know how to participate in today's webinar. You will have the opportunity to submit text questions to today's presenters by typing your questions into Q&A box at any time during the presentation. Please mention your name or organization and to whom the questions are posed. We will collect the questions and address them during our Q&A sessions. There will be a presence form post chat room in Zoom. Please fill in. You will receive an e-certificate for this webinar participation via email within 5 working days at the latest. And the webinar presentations materials will also be sent to your email. And this webinar will remain in YouTube channel MKI IEPS after this event finishes. Okay, and distinguished participants, ladies and gentlemen, let us start our webinar today by having speech which will be delivered by Mr. Wiluyo Kusdwiharto, Chairman of the Indonesia Electric Power Society. So, Mr. Wiluyo, the Zoom floor is yours.
Thank you, Mbak Ana. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Our distinguished guest, Mr. Ahmad Gunawan Wicaksono, as the Director of Verification, Hazardous and Non-Hazardous Management, Department of Forestry and Environment. Our distinguished guest, Dr. Akira Ohnaka, the Director of Research and Development Department, CICOL. Our distinguished guest, Dr. Pat Yung Ho from Seragreen. Our distinguished guest, Mr. Trisno Tio, as a Director of PT Seragreen Indonesia. Our distinguished guest, Mr. Yamin Pakaya, as a Director of PT Tinelo Poliama. Ladies and gentlemen, and all participants, thank you for joining us today. First of all, thanks to all of you that still be able joining this webinar today after the postponement for about 1 month to the restriction toward community activities in Jakarta area and nearby to avoid spreading of viruses COVID-19. This is the second webinar initiated by the Indonesian Electricity Society that focusing on FABA utilization. This webinar is an effort of the association to provide proper education to our community, investor, and the local government. Since the issuance of the government regulation number 22 year 2021 concerning the implementation of the environmental protection and management FABA fly ash, bottom ash has categorized as a non-hazardous and non-toxic waste. Hence, it could be managed and processed into a material that is very beneficial to the community nearby the power plant. Distinguished ladies and gentlemen, it has been a long time and many studies have been carried out in Indonesia to determine the chemical composition of FABA and its toxic properties using the International Toxic Characteristic Listing Procedure or TCLP, a procedure that for testing the toxic characteristics of a material. Using this TCLP, 16 types of dissolved heavy metal were identified and measured, and concluded that all of heavy metals concentration in the sample is away or below its permitted level, indicating that FABA is a non-toxic material. In addition, lethal dose 50 or LD50 test has also been carried out. The test also concludes that the FABA is a non-lethal material. There are also 35 developed countries in Europe, America, and Asia that produce FABA, including Asian countries that using coal from Indonesia, has included FABA as a non-hazardous waste. Most of FABA producers in developed countries have also used FABA for various activities, including as a raw material, a substitute material, or additive material. The level of FABA utilization in developed countries has been reported to reach for more than 70% in year 2020. Reportlinker.com also reported that the global fly ash market is accounted to US 6.8 billion in 2018 and is expected to grow at 7.9% rate during the period 2016 to 2027 to account to US 13.5 billion by 2027. This indicates that the FABA utilization is economically viable. This condition is in contrast to what happened in Indonesia, due to the fact that in the past, FABA was categorized as hazardous material. Then its utilization is very limited for research and pilot project within the power plant area. From production side, assuming 80 million ton per year of coal consumption and each ton of coal contain 6 to 10% of ash, then FABA production in Indonesia is estimated in the range of 5 to 8 million ton per year. However, FABA utilization is only less than 1 million ton in year 2016. This FABA utilization ratio will decrease as its production will increase by almost double when the total of 5,000 megawatt additional new coal power plants come into operation within the next few years. Main focus of FABA utilization in Indonesia is suggested focus on simple technology application, but required a huge volume of FABA, which is mostly related to the construction of infrastructure across the country. FABA is also suitable material resources for construction application to replace cement at the rural area that has limited access road where most of coal power plants are also eco-located. Hence, it is the time for Indonesia regulator to learn from the other countries such as India, China, Japan, Korea, etc. as how to increase the percentage FABA utilization. FABA is very potential to be used for construction material, such as toll roads, ports, airports, bridges, paving blocks, pre-stressed concrete, road bases, train pads, residential houses, village roads, schools, dormitory, etc. To protect fine ash dispersion along its handling and transportation, regulator can also provide standard operating procedure to transport, store, and handling of FABA. There are many key stakeholders that can provide environmental to promote FABA utilization in a massive way. The first key stakeholders is the regulators, either local government or Ministerial of Forestry and Environment, who can play a central role in providing end-to-end policy to support FABA utilization. Ministry of Forestry and Environmental is suggested to provide a balanced approach between protection environment against economic value generated from FABA utilization as non-hazardous material. Local government can also implement a policy to restrict cement application for construction activities in area nearby the coal power plant, similar to that has been applied in India. FABA producer can provide capacity building in FABA utilization to most of local communities nearby the power plant. Researchers can also actively conduct a study in how production process of FABA utilization can be more effective and efficient ways. I believe all of us agree and hope through cooperation and synergy with all those key stakeholders, FABA utilization in this country can be increased through many applications. Prior, I am officially opening this webinar. I would deliver my appreciation to all speakers from GCOL, Sarah Green, and PT Pinelo Polyama for all of your participation. My special appreciation also delivered to all of company sponsors. Your contributions makes this webinar happen. Finally, I would like to declare the webinar to be open. Stay safe, protect yourself from the COVID-19, and stay healthy. Burung nuri bulunya kemilau, terbang kencang di tengah hutan. Pembangkit kita semakin hijau untuk lingkungan berkelanjutan. Billahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Pantun ini yang selalu menjadi ciri khas dari MKI, dari Pak Wiluyo membuka setiap eventnya menjadi lebih bersemangat. Tentunya thank you Mr. Wiluyo for the interesting speech on providing environment to promote coal ash utilization and in Indonesia. And the next agenda is the keynote speech by Mr. Ahmad Gunawan Wicaksono, the Director of Verification of Waste and Hazardous Waste Material, Ministry of Environment and Forestry. And we will still wait for Mr. Ahmad Gunawan Wicaksono to join with us in this morning event. And I'll remind you, ladies and gentlemen, in this webinar, we will discuss together about best practice for coal ash utilization and handling. We have so many speakers that has competence in this sector. We have Mr. Antonius from MKI, and also we have Dr. Akira Ohnaka, the Director of R&D Department, GCOL, and we have Dr. Park Yong-hoo, Chairman of Sarah Green from South Korea. And we will still wait for the Mr. Ahmad Gunawan. Okay, and the next agenda.
Yeah.
The next agenda will.
Hello.
Okay, the next agenda is the keynote speech from Mr. Ahmad Gunawan Wicaksono, the Director of Verification of Waste and Hazardous Waste Material, Ministry of Environment and Forestry. And now, without further ado, I would like to invite Mr. Ahmad Gunawan Wicaksono to deliver the keynote speech. So, Mr. Gunawan, the Zoom floor is yours.
Thank you very much for the moderator. First of all, I would say that I'm very happy can join in this event, and of course, I also mentioned that distinguished to all participants and also distinguished guests from also speaker and all of the participants that included in this webinar. I heard already on the opening remark that a lot of fly ash will be produced in Indonesia year by year, even more, and for the next or in the future. So, as of course, the government also concerned regarding this, because actually this is a source. So, government fully support that this is actually can be utilized in the any aspect for the building material and so on and so on. So the new regulation in our new regulation regarding with the hazardous waste. First of all, I mentioned here that this is already excluded to the list of the hazardous waste. So the utilization can be pushed, and also utilization can be, much more easily in the implementing in the field. I also mentioned in this event that very important thing regarding with the new regulation. Our new regulation, we divided waste in Indonesia into two categories. The first of all is, of course, hazardous waste, and the second thing is a non-hazardous waste. And the other thing, non-hazardous waste, also divided into the two categories. The first of all is a special hazardous waste, and the second one is the listed non-hazardous waste. Now, listed non-hazardous waste is include the FABA. So that's why FABA is already excluded as a hazardous waste, but put it into the non-hazardous waste, which there is a subcategory for that. We call it listed non-hazardous waste. There is some certain rule, of course, in our regulation regarding with the listed non-hazardous waste. First of all, that this regulation actually is not different with other country. Many country, I would say. Why? Because each country is, during the during the implement of the utilization of FABA, they always use the standard. This is a very important thing. Always use the standard. Even just as a building material, there is a standard. As the a subpiece for the street, yeah, or the road, also there is standard. For the building, also there is standard for that. So that's why, like Pak Waluyo mentioned in the remark, that still developed to give more area regarding with the implementation of the hazardous implementation of the FABA. So that's why again, there's a government fully support for this. So please make standard as many as we can. Yeah. So hopefully that hazardous waste FABA can be utilized efficiently and effectively. And the next is regarding with the rule of our new regulation is there is no permit, or we call it there is no government agreement. There's because if the government agree, so that can be implemented. So in this area for FABA, because FABA put it into the subcategory of listed non-hazardous waste, so there is no need for the agreement from government. It's different with the normally of hazardous waste. And this is very important. But the listed non-hazardous waste have to put it into the document, environmental document. Yeah. So in the environmental document, we have to put it as one. First of all, of course, standard. Yeah. If I want to utilize my FABA, so what kind of the standard I will put it into the implementation. I will implement into the activities in our utilization, something like that. This should be put it into the environmental document. Yeah. The second thing is clear activities. Yeah, clear activities is mean that what kind of activities will be implemented during the utilization of our FABA. Yeah, this is very important also. So let's say I have 1,000 ton of FABA, and then 25% will be put it into the material building, and then the rest will be for the building, something like that. And this is our standard for the building, and this is our standard for the for the others. Something like that. First standard we have to put it, and then we have to know. And then the second one is what kind of the activities will be. Okay. And the next is, of course, reporting. Yeah, there's once a year have to make a report. What's the activities first of all, and then how much, and then where they will go or already go to a certain area, something like that. And then what kind of standard implement, what kind of the monitoring have to take it, something like that. So the question is, how about if there is no standard? So if there is no standard, we can adopt, yeah, we can adopt from the foreign country standard, something like that, yeah, from Japan, Korea, or whatever, yeah, that's already implement in certain country, and then they have a success story for that. So we can put it, and then we can adopt for that, yeah. And also, if there is something new for the utilization, with no standard, or even there is no standard for the country, so we can put it as a research. Yeah. So this research, again, government fully support for that. So fully support for that. Just mention it to us, and then we support for that. Yeah. Yeah. That's we recognize that so many FABA will be produced. So that's why government consider to make it easier, to make it can be implemented, because this is a resource, quite big resource, yeah, or even a huge resource in Indonesia. So can be replaced, yeah, or maybe can replace, yeah, can replace of something like soil or silica, and so on and so on. So, or even can be put it into the cement from the fly ash in the good quality. This is good idea. There's already some area already implement these activities. I think we have to support it and to continue this. The next is very important thing, yeah, and maybe can be consider in the UNFCCC COP or something next in the UK, I think, this year, yeah. So if we utilize, yeah, something like FABA, and then FABA replace the soil or maybe silica from the natural, yeah, can be make it benefit, so we can save our natural resource. It means also we can save our greenhouse gas, but this is not popular yet, yeah. So this will be, I would say, will be some what you call it, will be give the value, positive value, and also benefit even economically to the producer of the FABA, PLN, something like that. So PLN can get money if there is trading of the carbon dioxide for the next, in the future. So again, this forum, I would say that's a good idea, and also good discussion, hopefully in this webinar. can be explored, everything that can make a benefit to our country. And hopefully also there are, if I not mistake, if I will not mistake, that there is also other other speaker from Korea or maybe from other country will be give us some their experience. So we will hear this, and also we can join together, whatever can give a benefit together for our country. And the last thing that before I close, sorry, I cannot join because I have 10 have a meeting on maybe 9:45. This will be start our meeting, so I cannot join, but there are our colleagues also join in here. The last thing is also very important, that the FABA, FABA, it cannot be imported from other countries. Yeah, this is forbidden. Yeah, prohibited in our country. Yeah, so we cannot open our window, open our door to FABA from a foreign country. Yeah, so because this is our regulation mentioned something like that. Again, thank you very much for this opportunity to give our opening speak in here, and also just a remark and also a note in here. Hopefully that will be good discussion in this webinar, and also give a benefit to all of us. And the the last thing, that government fully support for the FABA utilization. Thank you very much. I give it to the moderator. Thank you.
Okay, thank you, Mr. Ahmad Gunawan. Thank you, Mr. Ahmad Gunawan, for the interesting keynote on Government of Indonesia policy in providing regulation to support FABA utilization. But before we proceed to the first presentation session, may I have one question for you, Mr. Gunawan?
Pass.
Okay.
Go ahead.
Could you explain how is the regulation and policy can support the FABA utilization to improve the community economic development?
Community economic development. Yeah, of course, this can be done. Yeah, for the FABA utilization in this area. Yeah, from the power generation can give to the community. Yeah, to make it better for them in the economic point of view, or maybe a wealth point of view. Yeah, but again, that this should be a record. Should be record in the report, in the yearly report first, and then this activity also should be put into the environmental document.
Okay.
Yeah. So so this is not difficult to to implement for this. I think this is easy one. Yeah. Thank you.
Okay, thank you once again to Mr. Ahmad Gunawan Wicaksono, the Director of Verification of Waste and Hazardous Waste Material, for the keynote speech and for the time. And now let's move to our next agenda of this webinar, ladies and gentlemen. In this first presentation session, I will invite the speakers of the session, Mr. Antonius Artono, Dr. Akira Ohnaka, and Dr. Park Yong-Ho. First presentation will be made from Mr. Antonius Artono, Head of Environment and Efficiency Department of MKI, and Again, as a reminder, the attendees have the opportunity to submit text questions to all presenters by typing your question into Q&A box on Zoom or via live chat on YouTube at any time during the presentation. Please mention your name or organization and to whom the questions are posed. We will then collect the questions and address them during our Q&A session. First presentation will be made from Mr. Antonius Artono, Head of Environment and Efficiency Department of MKI. And the Mr. Antonius Artono is also Executive Vice President Safety Environment PLN, Director Operation and Director Business Development PT Indonesia Power. Let's move to a presentation by Mr. Antonius from MKI. But before the presentation, allow me to read a brief biography of Mr. Antonius that from MKI, Department Diversification and Efficiency Energy, Safety and Environment, Executive Vice President Safety and Environment PLN, Director Operation and Director Business Development PT Indonesia Power. And your time is about 15 minutes. Mr. Antonius, the Zoom floor is yours.
Thank you, Mbak Ken, for introducing my CV. Hopefully that everybody can see this presentation. Just checking. Can you give feedback? Yes. Hopefully you can read it. Okay. Okay. Thank you. Good morning, ladies and gentlemen. So shortly I will present my presentation sharing about coal ash utilization and handling update status in Indonesia. This is probably just only to you that may not be familiar yet with how FABA is generated. Basically, FABA fly ash and bottom ash is produced through the process of burning process in the boiler. As we know that coal basically contain carbon that is we converted into heat, while inorganic material will be converted into ash collected in the upper top of the boiler that we call it fly ash. Mostly about 80 to 90% of the coal ash will be collected at the top of the boiler. And then also at the bottom of the boiler that we call it bottom ash, or with as short as bar, far and bar, fly ash and bottom ash. Some power plant also be equipped with a flue gas desulfurization unit. So this is to capture sulfur dioxide using calcium oxide to produce gypsum. So this is the basic concept how FABA is generated. To you that may be not familiar yet. Fly ash properties. So this is in general. Of course, the properties of FABA is depend on the source of the coal itself and also the chemical composition. Basically, the primary constituent will be consist of silica, calcium, aluminum, and ferroxide, and some amount of MgO and natrium oxide. The size of the fly ash particle varies from 10 to 100 micron, having a spherical shapes. The color is also various, so and also specific gravity. Due that coal before burning into the boiler, normally they have a pulverization process. So the particle shape and coal type is different on every power plant. Specific gravity ranging from 1.6 up to 3.1. Fly ash sourced from bituminous coal tend to be acidic, and those from subbituminous tend to be alkaline. However, this is heavily depend on the chemical composition of fly ash itself. This is the data to show how big is our FABA production each year. Basically, we can estimate from the coal consumption domestic in Indonesia. So this data showing production of coal, like we see here, that the production of coal in 2020 is about 560 million ton, and 330 million ton of it is exported, and only 131 million ton is used for domestic. If we assume that the coal contain about 6 up to 10% of wheat, then the estimated FABA production in 2020 will be ranging from 7.9 up to 13 million ton a year. So it is quite big. So the problem for Indonesia is basically how to utilize this FABA, this big amount of FABA as much as possible. And this is similar to other countries who also imported the coal from Indonesia. This is just give you an idea to you that may not familiar with Indonesian coal power plant across the country. This is data for 2019 that was collected by our colleague from PLN. So from the total coal consumption domestically, 138 million ton, about 90 million ton is used for electricity generation, and the rest is for cement and metallurgy and other purposes. So this is maps for location of power plant in Indonesia, which is mostly, of course, located in central Java, in Java Island. This is the projected FABA production in electricity sector. We can estimate the FABA production in electricity based on the coal consumption that we consume every year. This data, of course, is referred to a long-term electricity planning, or RUPTL, from government made by PLN in year 2019-2028, because this is the only document that issue officially, so then we only can refer to this long-term planning from government. This long-term planning, of course, not counted yet if there is scenario to close power plant, coal power plant in the future. Again, this is just to maybe to give you a highlight to what have been mentioned by Mr. Gunawan in the past, that the procedure to determine whether material is categorized as hazardous or non-hazardous waste. Actually, there are 3 different testing, basically, which is a characteristic test, which is consists of explosion, flammability, reactive, infectious, and corrosiveness. So this is the first test. And the second test is toxicity, characteristic leaching procedure. This is identify about 16 heavy metal that contain in the coal, in the ash, and determine whether the ash is toxicity or not. And then also the next step is lethal dose test, lethal dose 50 test. If the concentration of ash up higher than 15,000 milligram per kilogram body weight, then this accounted as practically non-hazardous. So these are the procedure how to determine whether a material is categorized as hazardous or not. What is the fact that FABA as a non-hazardous material? I think this is refer to the data that was collected and tested in PLN group. Basically, there is no negative test result from the material characteristic test, and also toxicity characteristic leaching procedure also giving the data that far below the minimum level, and LD50 is far higher than 15,000 milligram per kilogram body weight of mice, this testing object, and the radioactive also below than 1,000. Again, this is just summarized that finally the government of Indonesia issue a President Decree number 22, 2021, which is obliged to all waste producer, can be a corporation or a person, to manage all of the hazardous and non-hazardous material. Specific for non-hazardous material is categorized into two groups, which is registered non-hazardous waste, which is FABA is included in that categories with code number N106 and N107. As mentioned by Mr. Gunawan, the restriction for this regulation is open dumping is not allowed, and also open burning is also restricted. Mixing between hazardous waste with non-hazardous is also a restriction, and impounding at yard as the final disposal is also restricted. Again, this is also summarized what is the main content of President Decree number 22, 2021. As mentioned in Article 450 and 470, is basically consist of 6 sub categories. The first one is reduction. So every waste producer is obliged to conduct a reduction or volume of the waste before or after the production process. Any step that going to be done to do a reduction must also comply with environmental standard. The second one is the storage. So storage and impounding facilities must comply with engineering standard, and protection also have equipped with the protection to fight any leakages. So these are the main content in this storage issue. And then the third one is utilization. FABA, or in this case FABA, a non-hazardous waste, can be used as a raw material to substitute material or substitute energy, because some of non-hazardous waste also have some energy, so they can be used as substitute energy and also can be used as a side product. All of the utilization process must comply with standard and a national product standard Indonesia. So every product must comply with national product standard as mentioned by Mr. Gunawan. And as mentioned before, there is also discuss about border transportation in this regulation. In this President Decree, border transportation, we cannot import FABA, but conversely, we can export FABA in other countries. In case if the importer of FABA require categorized as FABA as hazardous waste, then the exporter must get permission from Ministerial of Forestry and Environment. And then mitigation and restoration. This is talking about if there is a pollution case conducted by a person or a company, then there must be mitigation process or mitigation acts, mitigation program that obliged to be conducted by that company or that person, or even can have a conduct environment restoration act. So that's depend on how severe the pollution case that was determined by a team that was appointed by the Minister of Environment and Forestry. And the last one was reporting. So this is basically we have to be able to report officially to the government, either district government or provincial government, and also to the Minister of Forestry and Environment about the type of waste, production date, storage time, and also the volume and the utilization as well. So basically we have to report it, what activity, what kind of waste that we produce, and what kind of activity that we utilize and the report must be conducted at least once a year. Even though there's already issue Presidential Decree number 22, 2021, but also still under discussion at operational level that require a ministerial decree for 6 items. The first one is a procedure to reduce non-hazardous waste, and then facilitate specification and requirement to store non-hazardous waste and utilization procedure, facilitate specification and requirement to impound non-hazardous waste, environmental restoration and mitigation if there is any case of environmental case, and then the reporting. I think this is in general, there are 2 big categories of FABA utilization. The left side here is mostly using a simple technology, low capital investment, and require huge amount of FABA, even though there is a lower economic value. The activity can consist of road construction, soil amelioration, zeolite, absorbent, and construction material. So those all of this activity basically require a simple technology, but require a huge amount of FABA. So this is activity is now very suitable to Indonesia because we have a big amount of FABA production. On the other hand, on the right side, this activity may require some higher technology, higher capital investment, but require limited amount of FABA compared to the other side. But in contrast, they have a higher economic value. This is the table. Yes.
Your time is about 2 minutes left.
Okay, I will make it speed faster. Yeah. This data showing the summary of FABA utilization. This is collected from many other sources, from PLN, Indonesia Power, PGB, and Tanjung Jati. We have not get information yet from IPP Indonesia. So if you are any one of you that may have data from IPP, then please contact me so we can monitor what kind of activity that we have. So we can update time by the time, so we can see what the progress that we have nationally. I think this is quite interesting. So once we contribute in updating this data, they can be more useful from time to time. This is sample of FABA utilization. I think in common, similar to other countries. The one that may be very rare is geomembrane. Yeah? Geomembrane. We have implemented one geomembrane in one of our power plant in West Java, the Labuan coal-fired power plant, that was to build a spoil bank, and also some making a house, and then also eco park and some of the activity like a corn block production, also research for ameliorant for planting rice, corn, and onion at Ombilin coal-fired power plant in West Sumatra. I think this is also a partnership option. Basically, there must be a good cooperation between coal manufacturer, between FABA producer and also company like construction companies. This is one that we also mentioned previously, MOU between PLN with construction state-owned companies to try to utilize FABA to build an infrastructure in Indonesia. This we identified quite a big amount for toll road, hydro dams, and also harbor and airport in this country. So hopefully through this cooperation, there is still some step to do, but I believe this can be a good solution for both parties between power producer and state-owned company construction. This is other option. So cooperation between FABA producer and company who need a construction material, so can become depend on the purpose, can be as a part of social responsibility for coal for as coal producer, but also can be in a commercial basis, yeah, on the left side. Joint cooperation between coal power plant is located in the power plant complex, as mentioned by Mr. Gunawan. So basically, if coal power plant environment permit already mentioned included in the document that there is a FABA utilization, so there is no permit that required to build and facilitate inside the power plant to utilize FABA. The only thing that we need to do is actually, when we produce a kind of production, that production must comply with standard national Indonesia. And there is a certain procedure for a company or for a person to get a standard national Indonesia, SNI, SNI. There is a certain procedure at the department beside Ministerial of Forestry and Environment. This is for handling and safety. I think this is standard. Basically, every power plant must comply with operating standard to avoid any dispersion of fine FABA to disperse in the air, so make it clean and healthy. So to do that, we have to maintain the moisture in the FABA and also do some compacting activity to avoid any dispersion of fine FABA to the environment. I think that's all of my presentation. Hopefully that can give you an idea that when we can discuss further in the next session. Thank you.
Okay, thank you, Mr. Antonius Artono, for the interesting update regarding the status of coal ash utilization and handling in Indonesia. And as a reminder, all attendees have the opportunity to submit text questions to today's presenters by typing your questions into Q&A box on Zoom or via live chat on YouTube at any time during the presentation. Please mention your name or organization and to whom the questions are posed. We will then collect the questions and address them during our Q&A session. Okay, let's move to our next agenda, which is a presentation from Dr. Akira Onaka, Director of R&D Department JCO. But before the presentation begins, allow me to read a brief biography of Dr. Akira Onaka. Professional highlights. Start from professional highlights. Mr. Onaka, originally a chemical engineer, has been consistently engaged in the development of coal utilization technology and coal ash effective utilization technology throughout his career. Start in 1985 with the development of fluidized coal fuel preparation technology and evaluating method for spontaneous combustion of low-rank coal. From 2000, he worked on the demonstration project of granulated geomaterial production technology using coal fly as a raw material and completed a commercial plant with an annual production capacity of 70,000 tons in 2004. And after that, for about 10 years since 2007, he conducted research and development work on low-rank coal effective utilization technology, such as lignite upgrading technology, and examined measures to expand lignite of use in Indonesia. And since 2018, as Deputy Director or Director of the Research and Development Department of JCO, he led the development of effective utilization of coal ash, focusing on expanding its usage and promoting its spread both in Japan and overseas. And now, Dr. Akira Onaka, the Zoom floor is yours, and your time is about 15 minutes.
Okay, thank you for my introduction and good morning, everyone. My name is Akira Onaka. I am working for coal ash related technology development at Japan Coal Frontier Organization, JCO. The title of my presentation today is Coal Ash Utilization in Commercial Practice and its Handling in Japan. I'd like to talk about coal ash utilization status of Japan and our JCO effort to expand the amount of coal ash utilization about technical development and business environment. Today, I will explain the 5 contents as shown in this slide. First of all, I will refer to the Japanese law and regulations on the management of industrial waste, including coal ash. The next content, I will talk about the status of effective utilization of coal ash in Japan compared with other countries. After that, I will mention about expected direction for expanding the amount of coal ash utilization and our J-Core's approach. Finally, I would like to introduce some example of the use of coal ash for realization of a carbon neutral society. This slide indicates simplified concept structure of Japanese management and handling regulation for industrial waste. It is classified as industrial waste when coal ash is generated at coal-fired power plant. Later handling method difference is depending on whether or not used for the effective material as variable. The coal ash will be treated as a product in case of effective use. After intermediate treatment, and will not consider as industrial waste, but it seems as variable. In Japan, it is very difficult to find a place to set up a management disposal site for final disposal. So the cost of both installing and maintaining of this management disposal site may be so high. So I believe this is the driving force of actual promoting for effective use. This slide compares the regulation of each country and the environment-related laws of coal ash classification. All country is classified as waste, and until last year, it can be confirmed that each country, except Indonesia, defined coal ash as not dangerous substances. However, as you know, in 2021, this year, coal ash was excluded from hazardous and toxic waste, abbreviated V3 waste in Indonesia. And it is highly expected that effective utilization of coal ash will progress in the wider range of application in the near future. From this slide, I will explain the production and the utilization of CCPs compared with Japan and other countries in the world. In this table, it is compared the amount of coal ash production and effective utilization rate in countries around the world in the 2016 cross-section. On the global average, you can confirm the effective utilization rate is 63.9%, while 93% in Japan is a significantly high percentages. This graph shows a balance between coal ash production and effective use in Japan over the last 25 years. The bar chart indicates the amount of coal ash production and effective use. A line chart is a plot of the trend of effective utilization rate. As shown on the left side of the figure from 1992 to the early 2000s, we can see the coal ash production is increasing. At the same time, the effective utilization rate is steadily increasing. Since then, Japan followed a high effective utilization rate, and the most recent 2018 results show that the amount of production is 12.65 million tons, and the effective utilization rate is about 98%. In this slide, I would like to consider how Japan achieved the effective utilization rate up to 99%. Let's take the change of effective utilization by field. The amount of coal ash has been increasing gradually since the 1990s. Faster than this, the amount of use in cement raw materials application has been increased. This is due to less limitation of ash quality in the use of cement raw materials. compared with other fields such as concrete admixtures. From this slide, based on our latest statistics data from 2018, we can check the effective utilization rate by field. In this pie chart is more clear. About 2/3 are used for cement raw materials in Japan. The next most common is in the civil engineering field, but only about 15%. In the slide, chemical composition of cement production and each raw materials compared with that of coal ash. The bottom of this table indicated the chemical composition of cement product. This chemical component of coal ash is similar to clay materials. So it can be used as a substitute for cement raw materials. Based on this, Japanese cement industry has developed the technology that can be used many kinds of industrial waste and alternative raw materials or alternative thermal energy sources. This scheme has helped to save the natural resources and extend the life of landfill site. This slide shows the cement manufacturing process in Japan. In the cement manufacturing process, the coal ash is effectively used in the raw materials process and finishing process as cement admixture before blending cement. In the finishing process, it is used as a mixed material for the mixed cement. In Japan, please confirm here that fly ash is mixed at the outlet of finishing mill. In this case, it is required to be a fly ash that conform to fit the Japanese industrial quality standards. In addition, it is also used as a concrete admixture in ready mixed concrete production in a similar method. In this slide, the cement manufacturing process in Indonesia as shown in this slide. As for the cement manufacturing process in Indonesia, coal ash is also used in the raw material process as marked 1, and finishing process as a cement admixture for blended cement, mark 2. Please confirm that in Indonesia, fly ash is fed to before milling at first finishing process. Compared with the Japanese finishing process, it may be possible to extend the available fly ash quality range at finishing process. This is because fly ash is further parabolized in the finishing mill, which may reduce the required particle size fineness. It can be more coarse size of fly ash. This slide showing the change in cement production in Japan and also indicate the amount of coal ash used in one graph. I think you can see it more clearly. Cement production is in the decline. The utilization rate of ash per cement production continue to increase, and it has achieved about 40% now. From this slide, I will talk about the methodology for the effective use expansion of coal ash in Japan and J-coal approaches. This graph is same as I explained earlier slide, a pie chart that shows the effective utilization percentage by field. For the purpose of expanding or keeping effective use, I believe that there are 3 important areas of the utilization. The first is for cement raw materials application. The second is application of cement mixing materials and concrete admixtures. Japan is particularly characterized by its low volume in this field compared with other countries, including Indonesia. There are restrictions on quality standards in Japan, and classification process are required for at the power plant site. In order to promote use in this field, instead of stricter quality standards, we should be moving to stable quality management method. Currently, the third field of civil engineering is focused on the most new business and expanding in various parts of Japan to expand the spread of mixed materials products. JCOL is also working on this field as a Fukushima Eco project. In the field of civil engineering, a technology called coal ash mixed material is used for manufacturing geomaterials. Several technologies have been developed to process coal fly ash into geomaterials in Japan. It is a technology to produce a substitute for soil, sand, or stone by such as granulation or a clashing process. Example of coal ash used in civil engineering, marine and port construction as shown in this photograph. In the case of use as a concrete product, applications such as tetrapod and fishing reefs have also been promoted. I would like to introduce two JCOL initiatives to expand the use of coal ash mixing materials. The first is the design of guideline to promote civil engineering usage. In March of this year, a guideline of design and manufacture and construction method of coal ash mixed materials for geomaterials was published from the Japan Society of Civil Engineers. The second is the start of the Fukushima EcoCrete business to manufacture the crash stones. This project produces artificial crash stone using coal ash as a raw material. In the final chapter, I will introduce examples of development of coal ash utilization technology for the realization of carbon neutral society. The government of Japan, Ministry of Economy, Trade and Industry has formulated the carbon recycle technology roadmap that shows a path to expansion and dismission of carbon recycling can be used CO2, carbon dioxide as raw materials. This roadmap included carbonate. This is manufacturing technology for carbonates, concrete product, concrete structure, etc. In particular, concrete products are positioned as an important theme aiming for earlier commercialization. As I explained so far, I pointed out that we should focus on the concrete field and the civil engineering field as two important fields that are effective in expanding the use of coal ash. These two fields should be paid attention to the effective utilization of coal ash and the possibility of fusion with low carbon technology. Carbonization, such as calcium carbonate, is in a manufacturing process of concrete products, and geomaterials is very important because it can lead the realization of carbon recycling. From here, I would like to introduce some example of the development of carbonization technology by Japanese companies. The first example is the CO2 Suicom development by Chugoku Electric Power and Kajima Corporation. CO2 Suicom means absorbs carbon dioxide in Japanese. They have jointly developed a new ecological concrete CO2 Suicom, absorbing a large amount of CO2 and keeping it fixed inside. CO2 Suicom is put to the practical use as variable precast concrete product. The second case is a research and development project in which JCOR is also participate. We are working on the development of CO2 fixation system for combustion ash, and the material manufacturing use carbonated ashes. The combustion ash can be absorbed CO2 is not limited to coal ash, but also include biomass combustion ash and also landfill coal ashes disposal site. At the power plant site, we are aiming to utilize carbonated coal ash in various effective fields by developing carbon dioxide absorbing process and materials manufacturing using carbonated ashes. In the landfill site, the aim of CO2 fixation to coal ash promote early stabilizing treatment and simplified maintenance and management of disposal site. In this slide, I would like to introduce research base using various research and technology development towards the early commercialization of carbon recycle technology. This project was started in 2020 and as a NEDO program, and JCOR is also participating. Currently, the research base is under construction in Osaki, Hiroshima Prefecture, the western part of Japan, and various research and development programs will be carried out until 2025. Finally, I would like to summarize my presentation. Japan promotes not only recycling of resources and the effective use of waste, but also actively establishing strict standards for waste disposal and management. Based on this background, the effective utilization of coal ash has now reached a maximum of 99%. In the field of this effective use of coal ash, the use of cement raw materials accounts for a large percentage. In recent years, technological development and commercialization efforts aiming at expanding in use in the civil engineering field have been particularly activated. I would like to summarize my presentation today with my strong expect for this effort in Japan will become a model case also in Indonesia to lead coal ash utilization expansion and also realize the carbon neutral society. Thank you for your attention. テレマカシありがとうございました。
Arigatou gozaimashita. Thank you, Mr. Akira Ohnaka, for the presentation, such an interesting presentation for us. Absolutely. Thank you, Mr. Akira Ohnaka. And as a reminder, all attendees, I would like to remind you that you have the opportunity to submit text questions to today's presenter by typing your question into Q&A box on Zoom or via live chat on YouTube at any time during the presentation. And please mention your name or organization and to whom the questions are posed. We will then collect the questions and address them during on our Q&A session. So let's move into our next agenda, which is a presentation from Dr. Park Young-ho, Chairman Chara Green South Korea. But before the presentation begins, absolutely allow us to read a brief biography of Dr. Park Young-ho. Dr. Park Yung-ho is the director and chairman from the Chera Green industry from 2012 until present. And he has been Chera Green Korea as a president and CEO from 2001 and until 2011. And also as president and CEO on SSDL Limited of Canada and director of Panamasia Corporation PAA of Hawaii in 1987 until 1995, still Mill Consulting. And now your time is about 15 minutes. Dr. Park Yung-ho, your Zoom floor, the Zoom floor is yours.
Thank you very much. Hi, my name is Young-ho Park. Before I start my presentation, I'd like to address some correction. I know that a lot of the people over here are, they're doctors and so forth. I'm not a doctor, but Chera Green has a lot of doctors working with us. The Chera Green was established in Korea 2000 under the sponsor of the government of Korea, and with a lot of the professors and engineers from the Cheonggi University Engineering Department. And what our aim was that we utilize industrial waste into resources. First, let me share the. Can you see?
Yeah.
Okay. Well, we actually utilize all the industrial waste, such as coal ash, bottom ash, steel mill sludges, all the industrial waste that you can think of. We make it and stabilize it and make it into aggregates. And to make it simpler, as we know, as the industry developed, there's many type of waste, such as general waste, and we can categorize the other waste like a hazardous waste. And good example of the general waste, one bottom ash that we're talking about from the coal ash, stone ash, sewage sludge, or hazardous material that contains a lot of toxic material like electric arc furnace dust, incineration ash, sewage sludge, and so forth. So, but today we're talking mainly about the coal ash problems that most of the countries that operates the coal power plant has. For Korea, about 10 million tons of the coal ashes are being generated from coal-fired power thermal power plants every year in Korea. And out of there, 70 to 80% gets recycled, mainly to the ingredients of the cement. And rest of it, the reject ashes and the bottom ashes end up in the coastal landfills. And actually, coal power plant comprise about 36% of Korea's electric power generation. And next is the nuclear power, and after that is the gas and renewable energy. So in order to operate the coal ash power plant, you need to deal with the waste that arises from the power plant. So you need a big ash pond. You see, this is a picture of the Yangwon power plant, one of the largest coal power plant, situated about 30 miles away from capital of Korea, Seoul. And you see this reservoir of the water. This has been taken around 2008, so about 13 years ago. And right now you see a lot of water, but that place looks like a lake, has been already, 70% has been already filled with the bottom ash. And the power plant has to run for another 20, 30 years, and we're running out of space where we can actually store the bottom ash. This is another power plant called Samcheonpo Power Plant, located in the south of Korea. You see, this is one of the oldest coal power plant, and where my cursor is pointing, this place, and this is the area where they store bottom ash. Right now, all those places are all filled up. There's no more place for you to really actually store any bottom ash. So the problem is, what do we do with this bottom ash? But we need a coal power plant because Korea depends more than 30% of the
electricity generated is from the coal power plant, excuse me. But let me give you one example of the coal ash pond that ruptured in Kingston, Nashville. This is a picture of the Kingston, Tennessee in USA. This what looks like the lava flow. Actually, it was the coal ash bottom ash storage, and the bottom ash reservoir ruptured from the bottom of the ash pond, and it actually it wiped out all the residents that was situated surrounding the lake. So the problem is that what Sarah Green, with the doctors and with the help of the Science Department, Ministry of Science Technology of Korea, we have come out with a solution where we try to make the bottom ash into resources, which is aggregates. Aggregate is the pebble that you mix with the cement to make the concrete. And there's a lot of use of it. And we make the live aggregates artificially. And it's got the high value construction material it is. It's lightweight, strong, ecological, and fireproof and soundproof also. This is the recycling plant that we have built next to Yongin Power Plant that you have seen in the picture previously. It's a 3,400 megawatts at that time, and we utilize from the one boiler that releases dry bottom ash. We use that to make an aggregate, and this plant is an aggregate factory that is built adjacent to the power plant. We believe that recycling has to be done within the facility, within the perimeter of the operation where the waste is being produced and generated. And the bottom ash to lightweight aggregate recycling, the key success factors are: one, know-how in raw material formulation, best and optimum mixing ratio depending on the quality of each particular raw materials. And two, secondly, know-how in controlling the sintering process environment to produce lightweight aggregate that fulfill the required specification in terms of strength, size, and other characteristics. And Sarah Green, I believe, with the help of all the doctors, by the way, doctors happen to be the shareholders of the Sarah Green, has acquired this know-how due to its continuous research and development efforts. And we have learned to achieve the know-how to do that. For instance, this is our main technology. That is, we utilize the porcelain tannery meter to grouping all the different industrial waste. For instance, you see the yellow marked bottom ash, paper ash. This is the waste that arises from the producing paper. Molding sand is from the casting sands from the factories. So we can mix and find its unique characteristic of the waste, and we make it into ceramic, like a brick or aggregate, by sintering it at a high temperature and with a glassification, so it becomes very hard. And this is our procedure recycling process, which first is an ion exchange. We make sure that our ingredients are mixed well, and there's an exchange of ions. And the next one is that we sinter by heating it at the rotary kiln or sintering chamber at the high degree to make it glassification, to make it high. For example, you take the lava rocks from the volcano, and all those rocks are very light because of the pore in the rock, but it's not dense enough to use it as a rock. So we make sure that by heating it and sintering it in a rotary kiln, that there's a glass that surrounds around this pore, making it hard and dense. And this is our bottom ash to lightweight aggregate recycling plant. And you have the power plant and fly ash. About 80% of that goes to raw material for cement. 20% gets either ash valley or to the ash pond. And we make it using the rotary kiln to make the high value lightweight aggregate, which can be built like a high-rise buildings, or use it in civil engineering to build the bridges. And lightweight aggregate, other application is that lightweight aggregate can be used in various applications such as structural lightweight concrete, non-structural lightweight concrete, geotechnical engineering, and road construction or horticulture. And we targeted to make a structural lightweight concrete where we can build high structure building utilizing these aggregates. And another use is that you can build a bridge, elevated structure, concrete roadway or highway, building mild and high rise, and upgrade or expansion of the existing structures, load-bearing structure members like decks, girders, piers, beams, columns and slabs, and etc., offshore platform, and other type of a structure, heavy constructions it can be used at. And the advantage of using lightweight aggregate is it varies. And first, it's light. It's lighter than the normal rock. It's about 35% lighter. And it's usually, if you use this, faster construction time and greater design flexibility using the design innovation, not only with not that regular normal way concrete can give. So, and it improves seismic response and increases resistance to earthquake. And it's very economical and cost performance. Reduce overall amount of a building cost, and it's less reinforcing steel, which means the concrete slab that you make using this lightweight aggregate is light. So in order to support that, you don't have to have a bigger steel pillar. So you can use less material, which will turn to be a less cost for the construction, and up to 35% lighter than traditional units. Allow manufacturing of longer spans and larger size of the precast sections. Upgrade existing structure bridges, and allows renovation and capacity upgrades, wider, thicker decks, or additional floors without changing the main support foundation. And extremely low in shrinkage also. And you can decrease floor heights, reduce cost of installation and transportation, fewer construction workers, faster installation time, and smaller cranes, and for instance, fewer trucks, because it's lighter. And it's not only that, it's higher in thermal insulation and better thermal expansion, which means that it can reduce the need for the complex movement joints, reduce heating and air conditioning costs. It's an excellent sound insulation, acoustic absorption, because there's a pore in the rocks, and that will absorb all the sound. Higher fire resistance. You can make the wall using this, and since it has been already sintered at the high temperature, it's very resistant to fire. And high durability, minimal cracking, macro compared to normal weight concrete due to superior contact zone. And internal curing, which means because of the core inside, the cement, the bondage of the cement is much more adhesive. It sticks much better than using regular rocks. And high resistance in freeze and thaw and de-icing salts and chemicals and corrosion. So we try to make it to aggregate, because if you take the waste and you make it recycled products, and if that doesn't get used widely, then that becomes also another waste. And it's very ecological, it's very green, and it's safe in construction. Okay, this is our manufacturing flow process. It looks a little convoluted, so maybe and complicated, and this will explain much easier. And you have a boiler from the power plant, and you have a bottom ash, and of course fly ash goes to the as ingredients for the cement. And we transfer the bottom ash to the mill and make it fine powder, and we form, make it to rock looking by using either pelletizer or extruder. Then we transfer into the kiln for preheating, and we use either rotary kiln or any sintering chamber kiln to sinter it, and then we cool it and we store it. And this is our process, and we have done that. Now we're at the second stage of the development where we make it much better to use for the final consumer, like a construction company and wedding mixing company. So this is about what we did and what we're doing. And not only the coal ash problem that the industrial country has, we have all other industrial waste that is being generated. But today, since we are focusing on the coal ash, my presentation to you is what we are doing in Korea, actualizing and commercializing and the use of the bottom ash that is being buried in a ash pond. And I think I still have time, but I think my presentation is about to end. I just pray that, hope that everybody stays well and healthy. And before I wrap up my presentation, I'd like to thank each of you at this panel. And once again, I'm so honored and so privileged to be invited as a member of this panel. Since the industry revolution, electricity has been the powertrain for the development of the industry. And not until long ago, it was luxury. It was luxury even to think about the industrial waste. However, the industry waste has become our problem. Not only the problem of Indonesia, but global problem. I would like once again thank Indonesia Electric Power Society to walk in front line to resolve the industrial waste such as coal ash. I hope you all stay healthy during this pandemic, and I pray that you may enjoy well and maintain good health, that all may go well with you. Thank you very much. Terima kasih. Thank you very much.
Okay. Thank you, Mr. Park Yung-ho, for your interesting presentation. Absolutely. And okay, it's time for the first Q&A session. We are now going to take questions from Q&A box on Zoom. And to prepare this session, I would like to invite Mr. Antonius Artono, Dr. Akira Ohnaka, and Dr. Park Yung-ho to switch on your camera. And as a reminder, the webinar participant can still submit questions through the Q&A box on Zoom. So our first question is for Mr. Anton. The question comes from Januarti for Mr. Anton. Does the government's plan in RPJMN 2020 until 2024 mention about the policy of using coal as our source of energy? If so, then is there any connection between decreasing the hazardous waste material in RPJMN with the delisting of FABA from hazardous category? For the information, RPJMN also states about the B3 decreasing as the target.
Yeah, thank you for Bu Januarti for the question. I think there is no have not been issued yet the new RUPTL long-term planning for government. So we refer to the previous long-term government that was 2019 until 2028. But from the discussion that we heard, actually there probably some kind of scenario to close some coal power plant in the future, but we don't know yet, as long as there is no issue officially yet. But maybe our friend from PLN can elaborate that in more detail about that.
Okay. Enough from you, Mr. Antonius?
Yeah.
Okay.
But I think it's, as long as the coal power plant still in operation, this is we still need to have an idea how to utilize that coal ash, because this is a huge volume. Even though the coal power plant already been closed, that probably the coal ash still there. The operational of the coal may be closed, but coal ash may still be there. That may be also a good resources to be utilized as construction or any other purposes.
Okay. Thank you, Mr. Antonius, for the answer, and we are heading to Mr. Akira Onaka. The question comes from the same people, Januarti Jaya Eka Putri. I have a question related to the quality of fly ash in Japan. First question, it is related to the method of burning the coal. CFBC boiler may produce low quality fly ash as compared to PCC boilers, even though the classification and chemical composition is the same. Because of that, it is difficult to use it in ready mix because it decreases the quality of concrete. In Japan, how do you handle the low quality fly ash?
Okay, thank you for the question. In Japan, fly ash used for the concrete materials only limited 2 or 3%, and only for the pulverized coal fly ash. And the fly ash need to meet industrial Japanese industrial standards for using the concrete admixture. And the quality of particle size and unburned carbon content is limited. It's a very severe condition. So it may be, I think that it is very difficult to use CFE boiler fly ash used for the concrete admixture. And as for the cost evaluation, the particle size is controlled by classifier installed at the power plant site, but to control the unburned carbon, egress is difficult to control by economical base in Japan.
Okay,
Yes.
and yeah, you still have one question, Mr. Akira Onaka. The second question is, do you make any categories of fly ash quality and its utilization? And TOA General Contractors is going to develop a non-Portland cement product in Indonesia. Does GCO join the project?
I hope so, but the private business relations not talk about at this time.
Okay.
So, yes. So
Okay.
I will talk about the private.
Okay. Okay, Mr. Akira Onaka, you mentioned about the guideline. Do you have the English version to share with us? And what is typical problem for cement industry and other construction companies to utilize FABA massively?
Sorry, the guideline regarding
Yes.
the guideline. Yes, from the Japan Society of Civil Engineering, only for the Japanese edition only. So the many companies started to the geomaterial protection, but to use to combine with carbonate materials is increase the cost. To our main researching point, and to develop the technology is cost estimation. This is now on under developing.
Okay. Okay, thank you, Mr. Akira Onaka, for the answer. We want to heading to Mr. Park Hyung Ho. Mr. Park Hyung Ho, the question comes from Erwin Widodo to you. What about the production rate of LWA in Korea? Moreover, what about the usage trend? Is it increasing by year?
Well, the first production facility that we built in Yeonghung was supposed to be yearly production of about 200,000 cubic meter, which is very, very minimum use of the amount of the aggregate that is used in Korea. And it's the one of the really commercial scale factory that has ever built, first in the world we're doing. But you see, what you have to know is that in order we can build the safe one, which passes all the specification of the Korean standard, But the final user, like a cement, the ready mixing company or construction company, they will have to learn how to use that. So usage is not as big as we hope it would be, but I wanted to point out this: the lightweight aggregate factory has been around the world from the beginning of the 19th century. The only thing that differentiates ours is that we used ingredients as the industrial waste. If you look at the United States or Europe, even in Japan, probably some has in some prefectures in Japan, where there is a lightweight aggregate factory utilizing the natural soil or natural rocks. Like the United States have, every state almost has an aggregate factory. Europe does it too. What makes ours unique is that we have spent almost 10 years with the help of the Korean, the ministry, science ministry, and the help of the engineer doctors at the Gyeonggi University, come out how we could safely and utilize the various type of waste into making the ingredients for the lightweight aggregates. Now we have to educate the final users and how it can be beneficial to those final users. And we are in the midst of it. We're talking with one of the largest ready mixing company in Korea, and they are testing, and they're utilizing the amount that we're producing 200,000 cubic meter is just a minimum, but it's a start. It's a start, and it's a resource. Otherwise, right now, as you know, the best gravel to mix with the cement to make a concrete is a river gravel. We don't have that anymore. So we cut the mountain, and you are hurting the mountains. But this can be resources for the constructions, and I think that should explain.
Okay.
The question. Yes, thank you.
Okay, thank you, Mr. Park. Young-ho, you still have more question to you. What is typical problem for construction industries to utilize FABA massively?
One more, pardon, ma'am. Could you repeat one more time?
Yeah, what is typical problem for construction industries to utilize FABA massively?
Oh, to use fly ash and bottom ash directly in a construction industry. I don't think the bottom ash can be really utilized in the construction industry directly. Fly ash, although I know anything, the fly ash that contains less than 5% of the unburned carbon, that can be passed to use it as the ingredients for the cement. You can, and I know they've been doing that. Not only Korea, but several other countries, they're doing it. But I think bottom ash is the problem, because that you have to throw it away. There's not too much use of it, and we try to make that into aggregates where there's so much demand for it in construction industry.
Okay, Mr. Park Young-ho, the next question is come from Januarti Jaya Eka Putri to you. Using sintering technology needs also a lot of energy. What is the source of energy you use for sintering? Have you compared the energy consumption of this method with the CO2 emission and the cost or the price?
Well, yes, and not really. I wish that I had one of a doctor, who is our partner also, who is over here to answer all that. More, they can give you more scientific data, backup data. But I am the person who actually stayed in the field up in the front and really actualize and see the actual operations. And just from the side of the normal people, our plant looks like that of a cement factory, like a rotary kiln, big cement factory. And usually those cement factories are fueled by, initially ignites by the maybe diesel fuel or gas, and later on they use coal to do that. And ours, because some of the aggregates, I mean the ingredients, bottom ash contains a lot of unburned carbon, it actually burns within, where it makes less use of the fuel. But don't take my answer all the way, because we have a Dr. Onaga over here, who is much more knowledgeable about this field.
Okay. Okay, thank you.
Thank you.
Thank you, Mr. Park Kyung-ho, for the answer. And I still have the question to all speakers. FABA produced from power plant have various types depending on coal specification. Are there any specific specification for FABA that can be utilized? Maybe we'll start from Mr. Akira Onaka.
Unmute, please.
Okay, you're unmute. Your audio is still mute, Mr. Akira Onaka.
Sorry,
Okay.
please ask again. Sorry.
Okay. I'll read once more the question. FABA produced from power plant have various types depending on coal specification. Are there any specific specification for FABA that can be utilized?
So I think for the aim of carbon neutral society realization, so coal ash utilization is need to collaborated with carbon dioxide material production. So the carbon offset is very important issues for with using the coal ash utilization in the near future. So Japanese government also aiming to the carbon neutral society realization up to 2050. Thank you.
Okay, thank you, Mr. Akira. Yeah, okay, Mr. Park Kyung-ho, your turn.
If I may add, the bottom ash in Korea, the usage is very minimal, but some use it as a fertilizer. Some use after they screen it and they segregate the hard ones, small particles, but hard ones. They use it as a road filler. Before they put the asphalt, you can fill a road filler. But the use of that is so minimal. See, I think we are producing so much industrial waste. So I think we have to come up with a solution where lots can be used. And that's one of the reasons why we chose aggregates. Because in construction, building all the buildings, bridges, buildings, you need those rocks to act as give a densitiness, hardness in concrete. So yes, for that, to your question, bottom ash, yes, can be used as a fertilizer in Korea, and they use as a road filler, but the use is not much.
Okay, thank you, Mr. Park Kyung-ho. Mr. Antonio, it's your turn, your answer for this question.
Yeah, even though there is a difference between fly ash specification from one mining to others, but actually basically the content consists always from aluminum, calcium, and silica. Those three content material is actually very good for construction. So even though there are different specification from one to others, but actually still can be used as construction material or any purposes like fertilization or ameliorant. I think not different too much. Yeah. Thank you.
Okay, thank you, Mr. Antonius. And for the end of the Q&A session, maybe the panelists, you can give the closing statement that we discussed together about best practice for coal ash utilization and handling based on our based on our experience in another country can be collaboration that we can use to utilization and handling the coal ash. Maybe start from Mr. Park Kyung-ho, the closing statement.
Pardon, ma'am?
Yeah, the closing statement that we discussed together, best practice for coal ash utilization and handling based on the Korea Korea.
Well, as I mentioned, ma'am, earlier, my closing statement, that industrial, we have never thought of the waste. Now we're thinking about it because it's a problem to our society now. And 20, 30, 40 years ago, it was a luxury to think about it. But now we have to, because it's really hurting the people and the society. So I'm so glad that we had this chance to have this panel of meeting where Indonesia actually being of front to try to alleviate the problems of the coal ash. And this is a very problematic. Any country, and even this underdeveloped country, if they want to be developed, electricity is the powertrain of the industrial development. And I think still coal power plant is one of the way to really generate the electricity in safe and consistency. I'm sure Mr. Anton agrees with that. And I really, once again, I thank you everyone very much.
Yeah, you're welcome. Thank you. Thank you so much, Mr. Park Yoo-ho. Closing statement from Mr. Akira Onaka.
Thank you. The coal ash utilization in the world is technological basis already developed. So the most country is used for the coal ash is based on existing technology, but economically basis to expand coal ash utilization is another problem, and also we need to consider the to reduce carbon dioxide issues. So the coal ash utilization technology can be easy to combine to create a carbon neutral society, such as concrete admixture technology using using fly ash, and also easy to combine the geomaterial manufacturing technology to combine the carbon dioxide technology, carbonated technology. So we need to progress the next new direction. Thank you.
Okay, thank you, Mr. Akira Onaka. The closing statement from Mr. Antonius Sartono. Your turn.
Yes, thank you. So basically, it's good moment for Indonesia that we can see the technology to utilize coal fly ash is proven. We can see from the presenter from both countries, Korea and Japan. Regulator already gave open the door to utilize fly ash as much as possible, because not categorized as hazardous anymore. And also the only thing that we made it to consider as how to make it become a real business, so that's going to be sustained for business in the future. And we are in the same boat. Korea, Japan is same boat, so we can cooperate each other to utilize coal ash as much as possible. I think this is a good moment. Please share your contact, Mr. Akira and Mr. Park, so the audience here can also contact you after this webinar. Who knows, someday that you can with the cooperation between Indonesia and Korea and Japan. Thank you.
Okay, thank you. Once again, I would like to say thank you to all the panelists, Mr. Antonius Artono from MKI, Mr. Akira Onaka from Chikol, and Mr. Park Yoo-ho. And I would like to take a photo together with us, Mr. Akira, Mr. Park Yoo-ho, Mr. Antonius Artono. I will count down, and I ask to you to give the thumbs up for this webinar. Okay, I will count down. 3, 2, 1. Okay, thank you so much. Actually, there are so many questions that address from the Q&A box, but the time limit make there's can be answer all of the question. Sorry, due to limited time, we have to end the first Q&A session. The questions which are not answered yet will be sent to the speaker. Then the MKI will send the answer by the email. Thank you once again to all panelists in the session 1. And we are now having a break about 10 minutes. And enjoy our sponsor video. And I will be back immediately afterwards. Thank you, Mr. Akira, Mr. Park Kyung Ho, Mr. Antonius.
Thank you.
기원전 27년
27 years BC, the building called Pantheon Synagogue that has been built by the Emperor Agrippa of Roman Empire is one of the oldest construction buildings that were built during the Roman Empire era. The ceiling roof opening in the Pantheon allows the natural sunshine to come through and the shine the inside of the dome. In order to effectuate the beautiful occurrence, the height of the ceiling has to be elevated 42 meters. One of the main reasons that the ceiling of the Pantheon Synagogue dome ceiling does not have cave-in is because of using special construction material, lightweight aggregate that is lighter than the regular rocks. This time, we'd like to introduce you the principle of the light construction material that can float underwater called lightweight aggregate. There are lots of pores. We can control the density of the light aggregates, and it can be heavy and light as we want. We control the size of the pores inside the aggregate so that it can be served as a construction material that will possess various characteristics. Well, let's take a look at the house and compare the ones built by domestic artificial lightweight aggregates and natural ones. In order to find the difference, we have taken a sample concrete of one made with the natural and one made with the artificial aggregates. The one on the left one is a natural rock. The one on the right is the concrete that are made with the artificial lightweight aggregates. First, we decide to compare the hardness of the two. We put two into press machine and insert the pressure, and as the time passes, both of them start to break apart. Although the result shows that concrete comprised of the regular rock is later harder, the result shows that both can be used in structural construction building. But when it comes to heat insulation, soundproof, and density, artificial lightweight was much superior. If constructed by the artificial lightweight aggregates, because of the pores in the artificial lightweight aggregates, the density of the concrete becomes low, and the pores inside the aggregates decreases the flow of the energy transfer. Because of this, the sound transfer energy and heat transfer energy are lessened. The coal-fired power plant in Yeonghung Island near Seoul, domestic-made ingredients for artificial lightweight aggregates are produced right at this location. In order to generate the electricity when the coal are used, fly ash can be used in part of material for cement, and bottom ash, which now is impossible to recycle and being thrown into the ash pond situated adjacent to the power plant. As of 2009, annually, 8.5 million tons of coal ash has been produced, and out of that, 3.1 million tons is being thrown into ash pond. Waste treatment cost for the ash per year comes out to be $50 million per year. A bigger problem is that the lifespan of the ash pond will be dissipated after 3 years. Furthermore, annually the natural aggregates are being procured 200 million cubic tons per year. In April 6, a new factory was erected next to Yangon coal-fired power plant. It is the factory that utilizes the coal ash, especially the bottom ash, to make artificial light aggregates. By making artificial lightweight aggregates, it not only enhances the preservation of natural environment and also reduce waste treatment costs, also it creates more jobs. It is like killing 3 birds with 1 stone.
Okay, to all ladies and gentlemen, to all participants, welcome back to this webinar. Let's continue to our next agenda. The second discussion session will be presenting Mr. Trisno Tio from PT Cara Green Indonesia and Mr. Yamin Pakaya, President or CEO from PT Tinelo Polyama. I would like to greeting Mr. Trisno Tio, Mr. Yamin Pakaya. Good afternoon. Okay, Mr. Trisno Tio and Mr. Yamin Pakaya, let's start the second part of the discussion. Before we start the discussion, I would like to read the brief biography from Mr. Trisno Tio. Okay. Mr. Trisno Tio, as a director PT Cara Green Indonesia and also the director from PT Proenergi Utama at 2011. And Mr. Trisno Tio has been head of strategic marketing and key account manager for PT PLN from 2007 until 2011 in PT Siemens Indonesia, sales director of PT Vatek T&D Indonesia from 2003 until 2007, 2003 until 2007, and project director from Vatek T&D France from 2002 until 2003, and project manager from Schneider Electric from 1996 until 2002. have education, Masters in Management. HEC Paris, France, 1993 until 1995, and Electrical Engineer degree, Universitas Sumatera Utara, Indonesia, 1988 until 1993. And without further ado, I would like to invite Mr. Trisno Tio. Your time is about 15 minutes, and the Zoom floor is yours.
Thank you very much, Miss Anne, Madam Anne, yes, and all distinguished webinar organizer, MKI, also all the panelists, honorable panelists, and the team, and also all participants of the webinar that I cannot cite on by well. Thank you very much for the opportunity given. So let me go directly to my presentation slide. Okay. Okay. So basically, this is the first page, but I think I will spend some time on that. So the title says bottom ash to lightweight aggregate recycling facility. So first of all, let's look at the bottom ash. So as we know, typically, more generally, a coal power plant produce fly ash and bottom ash, where the names FABA came from actually. And from our previous discussions from Dr. Onaka and Mr. Pratt, we also know actually there are specifications for our fly ash. That is why actually we got a third term, which is called reject fly ash. Why reject fly ash are those fly ash that actually cannot be used by the cement industry. And also from the previous presentation, we have seen that in countries like Japan and in Korea, the utilization of coal ash waste is very high in Japan and also in Korea. One of the type of ash used was actually the fuel ash. The fly ash. Okay, so in this presentation, actually for Sarah Green, we are focusing on the bottom ash. Bottom ash recycling is actually much more challenging than recycling of the fly ash. So that is why we can see in the Mr. Park presentation on the Korean coal-fired power plant, what they put in actually in the ash pond are only the bottom ash and the reject fly ash that they cannot sell to the cement industry. And even that is creating huge problem for them. So for information, I think most of people attending this seminar already knows. Normally, the ash are created by the coal-fired power plant is around 80% fly ash, roughly, maybe more, sometimes 85, and between 15 to 20% of the bottom ash. So now we are talking about this bottom ash because this is one of the trickiest to recycle. And then lightweight aggregate. What is that? I think I don't want to repeat. Mr. Park has explained it. This material has existed already naturally and has been used. You see the video in Korean, the lady, nice video about the Pantheon 2,000 years ago, how they build all the dome and construction because they are using this lightweight aggregate. And you also see in the introduction of the video how actually it is very light. It's light here. So lightweight aggregate also is not new material. People has been doing it artificially since 100 years ago from soil, from other type of material. But in Sarah Green, as far as Sarah Green is concerned, we are actually using the bottom ash and converting it to the and reject fly ash, if there is, to the lightweight aggregate. So here I would like to share the milestones. What do we do actually in Indonesia? So when I say that, I mean I direct them to the subject to include the number, the name of PT Indonesia Power. So in fact, actually in as early as 2014, our team has finalized a feasibility study report on the bottom ash to lightweight aggregate recycling facility for Suralaya Power Plant. And actually, in this respect, I would like to thank the Indonesia Power team, PLN team also, and also special acknowledgement and thank also to Pak Joko Aso. I hope that he's somewhere around, and also Pak Anton that allows us the opportunity to do that. So quite a visionary, actually, permission for us to do such a feasibility report, as well as all the Indonesian power team, the power plant team that we have visited and discussed with several times. So in 2014, we make this feasibility report. I will show you just the table of content later on, because of the limited time. And in 2015, we have made, Sarah Green, we have made the sample production of the lightweight aggregate using bottom ash and clay soil from Suralaya. So not from Korea. All material is done using, we dispatch the material with the help of PT Indonesia Power. And what we found is that, number one, lightweight aggregate of many sizes and strength can be produced and are produced. Actually, it is done. And in fact, we set to here 1 meter cubic, which is quite a lot of LV using Indonesian raw material, Suralaya's raw material to Indonesia, and we are still storing it in a warehouse in northern part of Jakarta. And we can conclude that the lightweight aggregate made by Suralaya bottom ash has a very high strength quality and can be used for structural purposes. Because this is the Himalaya of the usage, yeah? It has the strength actually to be used in a high quality, high strength concrete. Yeah, of course, apart from that, you can use it everywhere in geotechnical, horticulture, and everywhere. Also the non-structural purposes usage for the panel, insulation, etc. So I just go very fast. This is actually the front page, what we are doing. So you have Dr. Kim from the Department of Advanced Science, Advanced Material Science and Technology of Kyungju University. Of course, our famous Mr. Park. And our homage actually to our late and very cheered and treasured friend, the late Mr. Toshihide Nakajima, who has been very instrumental in our efforts. And okay, this is me. So, okay, just let you see, you like typical one, you have executive, and then we are talking about aggregate and concrete. So, and then we also talk about, we spend a chapter, we write a chapter about the market. So in market, we are trying to look how we applied and the lightweight aggregates. And actually also what are our target market actually. So we can divide into two. Number one is maybe a cement company. And number two is the construction, mostly the ready-mix concrete company. So we do the certain market study, the comparison between ready-mix, precast market, etc., etc. And then we put the also the technical aspects. This is the bottom ash physical and chemical properties. Okay, what is it? I think this has been presented by Pak Anton also. This is general technical and physical properties. And then you have also the Sarah Green waste recycling technology and processes that has very fast, okay. And now, then we are zooming at the Suralaya side, and then we have a very brief financial modeling schedule, etc., etc. Okay, let me jump. These are the tables used. And I would like to show something actually. Many thanks to the Ministry of Environment and Forestry is representative Pak Ahmad. There is a keyword what he said, which is a standard. Now, when we do this feasibility study, actually our lightweight aggregate fulfills the standard of ASTM, American standard, Korean standard, and also actually there is Indonesian standard for structural and non-structural lightweight aggregate. And the strength, chemical, physical test of our aggregates produced in Suralaya actually passed this test. For your information, like what Pak Ahmad Wicaksono said already, if there is no standard, you can use, because I think the top standard would be ASTM for the civil engineering. Also very stringent Japanese and these Korean standard. And SNE mostly is actually inspired by the ASTM standard. Let me go because of time constraint. So these are just from the feasibility studies, what we did in the land requirement, the main production parameters, we are eyeing for 200,000 cubic meter per year. And then also we are making studies on the required raw material, which is very funny. When you see, even if today PLN stopped all the coal-fired power plant, we still have raw material for bottom ash and reject fly ash in Ash Valley S1, maybe for 40 years, for this size of plant, or maybe 60 years, yeah? It should be a much bigger plant. Yeah, so okay. And also, I would like to jump on the carbon neutral project. Don't forget, we can use gas burner. That is in the process. But most importantly, when we use this lightweight aggregate, we use less material, meaning that we achieve less carbon in producing other materials. We use less man hour, we use less transportation, it's easier to transport, and etc. etc. So actually, this is in line with actually carbon reduction. And I believe when you do a lot of the whole accounting about the carbon emission and carbon savings, it could be a carbon neutral activity. So now this is the required quantity. Okay. Now, in Korea, we are using the dredged soil. At first, in Suralaya, we have these issues because there are not so much dredged soils, and dredged soils are dredged, and then sometimes they are thrown back again to the sea. However, we found some these red clay or soil that you know, near Suralaya, people are doing a lot of mining of the aggregates, the natural aggregates, the stones, and then a lot of them are throwing that away. It is actually make dirty the roads, etc. And we kind of find this, and we have a trial before producing the lightweight aggregate, and it proved to be very, very good material. So we can conclude Suralaya has good bottom ash and also good other mixing material for the lightweight aggregate. So these are only the calculations that we have made, also rough calculations only about what's going on in Suralaya, what we need in order to make this 200,000 cubic meter of lightweight aggregate per year, which is very small. There is also an issue, very small for the ready mix company. Okay, even though it's already very big facilities for us to produce that. Yeah. So we need such a bottom ash. You see, you got fly ash. Of course, we don't touch that because at the time in Suralaya, at that time we still can sell the fly ash to the cement company, and then this bottom ash and reject fly ash. So this is only the illustration on the Suralaya coal ash production. Okay, how much it's okay, and then we go to this conclusion that I mean, in one shot, even if we close Suralaya today, we call all power plants today, raw material is not lacking. We still have headache, not for 5 years, not maybe for 30 years. So you need Pak Anton and also Pak William, you need 1 million ton. Close the coal-fired power plant, you still need 1 million ton per year of this. Okay, other technology is okay, but for us maybe for the bottom ash, very big facilities for 20 or 30 years to recycle. So these are very quick. I think Pak Wilio, Pak Anton, and all PLN team is well known of this is Suralaya. This is where we actually intend to our factory to be during the studies. These are the financial assumptions, like usual. Okay, and these are the benefits. Actually, only one word. cost. There are a lot of costs that we don't see because by implementing recycling, actually you save a lot of treatment costs, logistic costs, environment costs, all kind of costs actually for the key stakeholder like Indonesia Power. And also for the communities, yeah. So as you can see what has been presented by Mr. Park, there are a lot of sinisters in the waiting, especially with the SPONs. And also there are economical advantages for the ready-mix companies or precast companies, off-takers, and for the government of Indonesia. For the people, we make it a cleaner and less waste society. So these are only the certain project structures that we can do in order to pull out this project. And that is the end. I hope that I stay within the time frame given. I hope that also the presentation is clear. Thank you very much. Terima kasih. Thank you.
Thank you to your interesting presentation. Absolutely, Mr. Trisno Tio in the second session in this afternoon. And before we start, again, as a reminder, all participants, the attendees have the opportunity to submit the questions to our presenters by typing your questions into Q&A box on Zoom at any time during the presentation. And please mention your name or organization and to whom the questions are posed. We will then collect the questions and address them during our Q&A session. So let's move to our next agenda. Without further ado, I would like to invite the second panelist, the second speakers on this session, Mr. Yamin Pakaya, President or CEO of PT Tinelo Poliyama. Before we start the presentation from Mr. Yamin Pakaya, I would like to read a brief biography from Mr. Yamin Pakaya. Mr. Yamin Pakaya is a training coordinator Fairchild Semiconductor Indonesia, koordinator tim penyusun AMDAL, Presiden Himpunan Pemerhati Lingkungan Hidup, Direktur Utama CEO PT Tinelo Poliyama from 2009 till now, Sekjen Komite Karbon Baru dan Material Maju KBMM, Lembaga Kajian Nawacita, Kepala Bidang Utilisasi Municipal Solid Waste Masyarakat Energi Biomasa Indonesia, Wakil Ketua Komite Pemberdayaan Masyarakat Desa. Mr. Yamin Pakaya, your time is about 15 minutes. The Zoom floor is yours.
Thank you. Yeah, let me share my presentation. Moment, please.
Okay.
You can see my slide?
Yes, Mr. Yamin Pakaya. We all are accepted.
Good day, ladies and gentlemen. Thank you, Ken. My presentation is, as I meet the other presenters, but I'm focused on what is the technology I know to facilitate how FABA impale in the fuel cell. So I'm focused only fuel cell because why the materials of FABA is a supplement of the fuel cell. Why we're talking about the civil engineering, geo-engineering, geo-environmental, geo-mechanical in the why we put the FABA with fuel cell in the art. This is research from the university. Yeah, that various FABA. We can what's called. I can specify what is the math of FABA. Why FABA is very matching together with the gel cell, why we put in the R. Because on FABA has what's called material as the chemical material, also the physical material. This is something like we can call a volcanic material. And also the FABA, we can make become synthetic material, like Mr. Park say, what's called, they are patented, their product lightweight material. Also in the chemical side, the FABA becomes, we make a concrete additive, also geopolymers. Very bad with the gel cell, why we put together in the R. And then in the FABA also has a rare earth element, something like gallium, titanium, aluminum, etc. And this is studied by the Indian Institute. The Techmira, they said the in FABA contains rare earth element. This just becomes something like what's called. We can. Some people claim that better FABA we will use for the rare earth element. We take the rare earth element and becomes critical minerals, or becomes the embankment or infill material in infrastructure, road infrastructures. Then the what's called Wantanas, yeah, we can call national security, send a letter to me how to solve this FABA. What's the good to utilize? Because in FABA has contained rare earth element. I give the good solution. In landfill, PLTU, yeah, we set up something like a pre-treatment of FABA. This is like granular machine. Yeah, this the capacity 20 tons per hour. Is suitable for the how to solve the FABA as the what's called the residue or the byproduct of the PLN. Then okay, by physically we can spread what's the content. FABA contains rare earth element or FABA as a residue. Yeah, by physically we can spread, and then letters, yeah, the minutes to manage to process the rare earth element. It is different case. Give the professional. And then okay, this good because the percentage is very small while we what's called extract the rare earth element in the FABA. So the rest is very big, and then how to solve the rest? Yeah, and then okay, better we put in the art, like we can call something like cradle to grave, because not used. Okay, this is gel cell. What's the gel cell? Gel cell is a part of the type of the geosynthetic. And gel cell has parameters. And what is the competitor of gel cell while the civil engineering wants to use the geosynthetic? Only one. This is a geogrid. Also, you already know what's grid. Indonesia knows very well geogrid. But for a gel cell is something like we can socialization. Because in the manual book of the Bina Marga, not put gel cell in the manual book. So we have difficult to follow the tender and so on. But geogrids, okay, this is familiar in the Indonesian. Okay, this type of the gel cells, perforate and non-perforate, also combine perforate and non-perforate. Depends on the hole. here. Why they make like this? Because this in the gas cell, this is becomes something like we can call water drainage. While you put together the earth, this become dryness. Okay, this issue on civil engineering sector. Easy to install gas cell. This is becomes what's called labor intensive padat karya. Then we can what's called set up like this, becomes like this. This is what's called training in Tel Aviv, Israel. Because why in the patented. And then geocell is we can fill in or we can fill in with the FABA, also the concrete, also the vegetated, also the gravel, also the sand. This is what's called the material. And how to fill in the material and the geocell depends on recommendation of the civil engineering. I mean the design. Okay, to design to put the geocell in the earth, in the infrastructure, in the road like this. Yeah, in the building like this, in the paved road, we can put in the base course, subbase, also base course, also in the slope protection and retaining wall. This is what's familiar of the using for what's called geocell. What is the our relation with this webinar? We can change the embankment. Yeah, familiar with if we put the soil there, but we can also put FABA. Why? While FABA we already stated this is not hazard waste, okay, and then we can put the embankment. You see how many quantity if we put if we substitute the soil with FABA. So it's becomes the one of the issue to solve the problem over FABA, while FABA still stay in your landfill, PLTU landfill. Geocell is why geocell is not popular made with in fill in or made in FABA in the world, because geocell is very compatible or suitable while we use the recycled material, sand other mixed material. In the mixed aggregates, including what Mr. Park say, lightweight aggregate, LWE. While we use this material, fly ash, local sand, recycled asphalt, yeah, we no need to use the macadam, the stone, the rock. In the geocell technology, no need use macadam, and it's all based on. We substitute with the geocell. So this case is very what's called important, because environmental friendly and also carbon footprint, and also to what's called to solve the degradation of the earth while we mine the andesite, aggregate, Why use FABA? You use recycle asphalt, no need this stone. Okay, according to the research, okay, if we use local and recycle and also the FABA we can call as aggregate, you know. FABA is what's called a fine aggregate. Also, if Mr. Park make something like LW aggregate, this becomes a stone aggregate. Yeah. If you fill in the FABA in the carousel, this is to be increase the loading carrying capacity. Yeah, 13 times while we fill aggregates, 11 times what we fill sand fill, or 10 times if we fill wreck soil. Yeah. Okay. Let me play the video. How this the increase of the loading capacity. You can see the track here in the video. This is performance of geocell while we fill in FABA or local sand or recycle. This like this. You can see how the performance of the track is. Track is very. It's about 120 tons. The what's called the weight. Yeah, this is why? Sorry. Will be in like this. FABA we just put like this. You see the increase of the load carrying capacity. Yes, so this is the performance of the geocell while we fill in. Let's say assume is we fill in there what's called FABA. Okay, we have studied until now. I will collaborate with the Sinclair National Indian Institute Technology in Sinclair. Yeah, this is a fly ash of FABA. We mix it with the soil, and then while we put as a soil stabilization, yeah, the CBR will be increased like this. Depend on the percentage of the soil and the fly ash. And then we put, you use truck, a special truck vehicle, because to avoid the dust. And then they compact the special compactor. And okay, we are also studying about how to make a sintering. What's called the fly ash becomes lightweight aggregate, like Mr. Park product. But without our aiming is not target to product. We just only to make sure about the water content of the what's called the lightweight aggregate, and then suitable or met with the geocell while we put, because we have to calculate what is the CBR. Carrying bearing ratio, caliper bearing ratio. I mean the what's called the bearing ratio of the FABA, of the bearing ratio while FABA mixed with the soil. I told the story. In Netherlands in 2016. There is a seminar. They discuss about how to solve the problem, the soil problem, the weak soil, you know. This soil very weak. And then the ground level, water level is under 7 meters. While they make this becomes what's called a road. They study, okay, better put geogrid, also better put geogrid combined with the geotextile, and how to put the embankment. What's the material of embankment? Because they say it's good to put becomes the embankment material is residual material. not clear what they call residual material in this project, but I know this is fly ash and bottom ash. And then sometimes they call pond ash. Pond ash is combined between bottom ash and fly ash, while put in the something like in the one place, something like Indonesian called IPAL, instalasi pengolahan air limbah. Yeah, this is something like swim, kolam, and then they call residual. But the material I know is fly ash. And then how to solve about the column? Yeah, they say that, okay, we can put geopolymer. They stated that put geopolymer, all CFG. This concrete, yeah, fly ash and gravel. They make something like what's called column. Why they not use only concrete or gravel? Because this, okay, we can discuss in the civil engineering. And then in these layers, they put geogrid also together with the geotextile. Yeah, and then okay, how the performance is good until now. They say it's good. No settlement. Yeah, and then is the road is running well. This is that case, the above case. Okay, I learned deep in India. I go to the IITM. This is Mr. Professor Raja Gopal sign, because in Indian, you know, they have what's called the flyover. Yeah, this is the height like this, 6 until 12. You know. And in this is inside of this flyover is all fly ash. And then I want to know why this very strange and no settlement here. They say, okay, we put something like geotextile, okay, same in the Netherlands, and then they put in the top of the layers geogrid, but yeah, in the third stage, they put geocell. And until now, still well. I stand in the above of this what's called flyover. I want to know what's happened with the putting and petting. This is fly ash is suitable to avoid the putting. You know, if you by the road, you can see putting and patting. Something like a brick in the asphalt road or the concrete. This is okay. So it's meaning this pond, and then already 12 years. Okay, I studied also in China. China from Beijing to Shanghai, they buy the high speed what's called train. And then they use also same what's called design. They use this is geogrid, also the lightweight. And I know, yeah, this is the fly ash. And in China, in Beijing, okay, they use the stone column. They use CFG, concrete, fly ash, and gravel. Why? This is the secret of the civil engineering, to avoid the bugging. Once the soft soil and you put stone only, the stake, this column becomes bugging.
Okay.
Okay. This is it. What's called I studied, yeah, this clay, separated, and then the silt, and also, yeah, this is stone column they made there. Then I make this. I want to try what's the comment of engineering, especially shipping engineering in Indonesia. Area has a soil configuration like this. and then I follow tender there, yeah, Michael, even what's called Keller, and so on. And number 5, it's me, Tinelo. This long time, I'll discuss with the PUPR, with the engineering, with the professional. Then Hutama Karya confirm, okay, please, Yamin, you said the offering of your design. Okay, unfortunately, I got the something like what's called the segment of the what's called the road in Pekanbaru, very low soil. You know, this pit soil until 30 meters. Until 30 meters. How to solve? How to build a road in the pit soil, in the subsoil? This is impossible. But based on the this is analysis, okay, we try together with the Pusjatan. Pusjatan is pusat jalan dan jembatan, research body of the PUPR, yeah. And then this is civil engineering of Indian technology,
Okay.
Madras. This is Mr. Professor Raja Gopal in India, in Mumbai. Okay, we study we draw the how to make the road is what's called conform,
Okay.
and matching with the FABA.
Yeah.
Yeah,
Sorry,
because why?
Mr.
Yeah,
Yamin,
we
Bapak
follow why
India.
FABA. FABA is granular. Yeah, Mr. Parks knows very well. Okay, moment. Yeah. Okay,
Yeah,
this is
sorry, Mr.
layout
Yamin
of the gas
Pakaya.
cell, what we put in the ash foundation. Yeah, and John.
I just
Okay,
would like
me.
to
This is
remind
okay.
you.
We put in the embankment FABA also like this. Okay, no problem. Okay, this is in India. While you use unpiped road, we'll use 90% FABA, and this in Thailand, they make pavement from FABA. Yeah, and then how to put FABA in the road? It is like this. We make post, it becomes geopolymer or geopolycrate, and then we put the system like this. This is what's called the technology in Africa.
The slump comes out in 90 millimeters slump. It combines nicely with the previous material.
Yeah, all in 1 minute.
Measures without any cold joints or ball joints.
Yes. Confirm already in Africa, they use FABA for the pavement road. You see, yeah, this is PT1 MPA, the strength. It's very good, FABA. Okay, I summarize that why FABA we'll use in the with gas cell is okay. We can what's called fill in. We can adopt something like this presentation. Yeah, for the infill material 95 until 100%, we can adopt FABA. For embankment 90 until 100%. For what's called with mix with soil. And then and so on. And pavement like this, use geocell, use what's called pavement, geoprate, and geopolymer also like this. Okay, to put what's called to show you in the next future in the Timor-Leste, we will buy the project like this. We can see there. Yeah, I invite you coming to see our next project there in Timor-Leste.
Okay.
This is what is the methodology of the gas cell matched with FABA. I will use becomes matched with the PRS technology, and also from India. I learned very well about the geosynthetic, and then how the performance of the gas cell based on the new acceptable design by the mechanism and empirical. Okay, my company can design and can supply the gill cell and can execute while you are interested with this technology. Thank you very much, Ken.
Okay.
Back to you.
Okay, thank you, Mr. Yamin Pakaya, for the presentation. And now we are entering the Q&A session in session 2 on today's webinar. There are so many questions that we collect, and the first question is addressed to Mr. Trisnotio. Mr. Trisnotio, what is the challenge of utilization of coal ash?
Well, I think there are two ways to see things. Number one is to manage cost. Number two is to generate revenue.
Okay.
Because one of the most hardest thing is that to make it economical. So at the first of our development, for example, this actually should go to Mr. Park in Korea. The power plant, their first concern is that I don't have land. If I have to buy land. It's very expensive. It's very expensive to build ash pond, not landfill, but ash pond, etc., etc. Yeah. So I think this is the challenge to make sure that we can address the pain points, which is to avoid big costs. We should account it that for. And secondly, the other challenge is to generate revenues from this new product and not to make another waste out of the previous waste. Thank you.
Okay, thank you, Mr. Trisnotio. There are the challenge of utilization of coal ash. And the next question is still for you, Mr. Trisnotio. Which one is the best to utilize coal ash that is produced from low rank coal, medium, or high rank?
Well, for the time being, I think our technology can absorb a wide range of the coal ash produced by many power plants. Like Mr. Onaka said, there are also fly ash, if I'm not wrong, Mr. Onaka or Mr. Park, which has unburned due to the boiler process, high unburned carbon content. This is refused by the cement factory. This is what we call in the coal, even coal ash, the waste, they have specs. There are specs that the usual recycler, which is the cement factory, say, oh, no, we don't want this because it will alter, it will change our, okay. So basically our technology, as far as our technology is concerned, we can recycle all ashes, fly, bottom ash, FABA, and the intermediate one, which is fly ash, but with high unburned content. In our own internal term, we call it reject fly ash.
Okay.
So we have a wide range of operational, okay.
Okay. Enough for the answer, Mr. Trisnotio?
I think so.
Okay. Okay, thank you, Mr. Trisnotio. I would like to heading to Mr. Yamin Pakaya. Mr. Yamin Pakaya, still with us? Can you switch on your camera? Mr. Yamin Pakaya?
Yes, yeah.
Okay, sorry, can you switch on your camera, Mr. Yamin
Hello?
Pakaya? Okay. Okay, Mr. Yamin Pakaya,
Okay.
this is the question for you. What is the problem at the beginning step?
Share dong.
Okay, Mr. Yamin Pakaya, the question is what is the problem at the beginning step of utilization of coal ash?
Dian. Dikeluarin dulu ini saya.
Oh ya. Okay. We are trying to back to Mr. Yamin Pakaya.
Yeah. Okay. Can you hear me?
Okay, Mr. Yamin Pakaya.
Yeah. What's the question, please?
Yes, the question is, what is the problem at the beginning step of utilization of coal ash?
Okay, for the globally, it's no problem because they already did this technology. But why they choose the others what's called other material? Because it's according to the supply chains management. But why I use apply S if I have the PLN is very far, very jauh. Yeah, what's called from my site. Then they use only the local material. But right now, if Indonesian already release, already allow the fly S, bottom S, this good chance for us. Yeah. Now Indonesian, I hope becomes leaders to use fly S and geocell. Because why? Three field we can solve the problem of Indonesian. The post Indonesian is many subsoil. You know, our new capital is many subsoil. We have difficult to what's called to take the andesite there, the aggregate there. The second is okay. We can use a geocell because we don't need to use what's called something like conventional. Because also geocell we can use from waste, municipal solid waste. We take the plastic there and then again we can make geocell. So they also becomes to solve our national problem. And then this is, you know, the price is only 70% of the, if you compare with the conventional design, conventional way. Yeah, if your budget is 1 million, 1 billion, for me, for geocell, only 170, 100 billion. So meaning we save 30%. This geocell. Yeah, this good chance for us, Indonesian, while now the release the regulation of the geocell. Thank you.
Again, you have to unmute.
Sorry. Okay. Talk about the geocell.
I cannot hear your voice.
Yeah. How far geocell has been utilized in road construction and soil stabilization in Indonesia?
Okay, depends on the data of the Mr. Antonius while he's talking about civil engineering. Okay, Mr. Antonius say that the FABA used for the civil engineering only for geopolymer. Yeah, not with geocell. Okay, maybe any some company use for the plantation road in Kalimantan, but it is small size. Yeah, for the national project, never. Not yet. Including me already becomes the winner of the what's called the road in the Trans Sumatra. I cannot what's called fulfill that because we have the last year there is no regulation to release the geocell to use in the infrastructure road. But right now is the good timing. Because why the Kemenko Maritimes already released also, you know, in the Jawa Tengah, yeah, central of Java, there is a project there, and then it becomes challenging for us how to make geocell and FABA to use for the Indonesian road infrastructure. Thank you.
Okay, thank you, Mr. Yamin Pakaya. And the next question is all the speakers
Yes, enough.
in session 2.
Ken?
Yeah, okay, Mr. Yamin Pakaya, thank you for the answer. And the next question is for all speakers in session 2. FABA produced from power plant have various types depending on coal specification. Are there any specific specification for FABA that can be utilized? Maybe Mr. Trisnotio can be the first to answer this question.
Very shortly, due to time, as I illustrated in a very general, you know, FABA, fly ash, and bottom ash. And actually, in Sara Green Technology, we have a third category, which is called reject fly ash. So actually, in our respect, we are recycling the waste of waste, the bottom part of the thing. And there are coal ash specifications exist in Japan, Korea, and other countries. I'm not sure in Indonesia. I don't mean a coal specification, it's coal ash specifications, yeah. Mostly on the left carbon content, etc., either minerals, whatsoever. Should be there is, yeah. So we should base on that. I think also the cement company who actually buy fly ash, they have several parameters on that, yeah. Why it happened? Because you know, boilers don't. Not a lot of people are using the same type of coal as what was questioned before. Number two, boilers, as sometimes you design like that, it does not perform like that, and as it age, it be behaving not in the way you would like to. Okay, so that is why you have ashes that fly ashes that are rejected, but we recycle that as well as the bottom ash.
Okay. Okay, thank you, Mr. Trisnotio, for the answer. We are heading to Mr. Yamin Pakaya to give your perspective to answer this question, Mr. Yamin Pakaya.
Okay, for the FABA utilized together with the geocell for the soil stabilization, we have no problem. Any kind of FABA, any kind of fly ash, any kind of bottom ash. Because why? We have a technology. While a weakness, a strength test of the FABA, we can combine with the geocell. Because in the geocell and FABA, it's still matching together. Yeah, so we can arrange from the head of the geocell, we can arrange for the texture of the geocell, while FABA is not fulfill the characteristic to what's called to design. And vice versa. I mean, so no problem, any kind. Even subsoil we can do. Yeah, so it's the meaning why FABA. FABA is a good material, a fine material, aggregate material. So no problem. While FABA coal ash used in the geocell. Any specification? Yeah, especially in the FABA still has what's called hajar waste. Yeah, something like to influence the environment. Thank you.
Okay, thank you, Mr. Yamin Pakaya. And the closing for the session too in today's webinar, maybe Mr. Trisnotio, you can give closing statement. What we talk about in this discussion about best practice for coal ash utilization and handling in the future, maybe in collaboration.
Very happy to be invited. Hopefully, this is a good start for the lower waste society. Yeah. So number two, about our efforts also with PLN Indonesia Power. One of the most challenge, this is the final phrase from me, is actually when we did the research and everything, we are confronted with not only strength problems. Actually, our technology can be used even though the FABA is still classified in B3. Because when it is classified in B3, there are certain tests, leaching, environmental, this and that. So actually, we fulfill all. It doesn't matter for us whether it is in B3 or non-B3. That's it from me. And thank you very much for all distinguished guests and panelists for this sharing of information. Thank you very much.
Most welcome. Thank you very much, Mr. Trisnotio. Mr. Yamin Pakaya, your closing statement for this session.
Okay, while this is a good chance, I have to make something like what's called. I hope the Indonesian becomes very seriously to think about the FABA. This is a good time for us while President already signed to release FABA from the hajar waste, and then also while the KLHK, yeah, Minister of the Environmental Forestry already make something like a standard operation procedure. I asked what's called the PLTU in the local place. Yeah, ask the what's called the professional to join with you how to solve your problem FABA in your landfill, in your stockpile. This is good for us because Indonesian has problem about three fields. The first is the we live in a ring of fire, seismic problem, The second is we have problem about the aggregate, the mining. The third is we have problem with the many municipal solid waste, sampah. Yeah, while use is a berkah, blessing for us, blessing for Indonesia. Thank you.
Okay, thank you, Mr. Yamin Pakaya. Thank you to all session two speakers for participating in today's webinar in this session. Thank you to all participants that come with us with a question. For the rest of unanswered question will be answered by panelists and sent through to your email. Thank you once again. I would like to take photo together, Mr. Trisnotio, Mr. Yamin Pakaya.
Okay.
You can give your two thumbs up to this
Okay.
event. Okay, I will count down. 3, 2, 1. Thank you so much
Thank you.
once again, Mr. Trisnotio from Cera Green Indonesia, Mr. Yamin Pakaya from PT Tinelio Polyama. Thank you for the participation in this today's event. And we are now reaching the end of today's webinar best practice for coal ash utilization and handling. I'm Ken Anna, as your MC and moderator. I'd like to thank you for your participation, and I hope that this event will bring a lot of useful and insightful information for all of us. See you absolutely in another good time. Thank you. As closing on behalf of MKI, I would like to forward our thanks and appreciation once again to all speakers. And thank you also to everyone for attending today's webinar. Hope to see you again in the next event organized by MKI. Stay safe, healthy, and happy to all of you. As mentioned earlier, today's webinar is the 4th episode of MKI Smart Grid webinar series out of 10 episodes hosted by the Indonesian Electrical Power Society, Masyarakat Ketenagalistrikan Indonesia, taken place in April 2021 until January 2022. It's supported by PT PLN Persero and sponsored by Tide, Huawei, Capco, Hitachi ABB Power Grid, Siemens, ABB Sakti Industry, Trillion, G Grid Solution, Mitsubishi Power, PT Indonesia Comnet Plus, and in partnership with Think Smart Grid France and Energy Academic Indonesia. On behalf of the Indonesian Electrical Power Society, Masyarakat Ketenagalistrikan Indonesia, thank you for joining us today. We hope to see you all in the next episode of MKI Smart Grid webinar series that will be held on 12th of August 2021 on wide area measurement, protection, and controlling. We will keep you all updated on the detail via email. Thank you and have a great rest of your day. Thank you. See you in another
Thank you.
Bye.
Thank
Thank you.
Thank you, Pak Tio. Thank you, Mr.
Ya,
Pak.
Pak Wiluyo,
Thank you,
Pak
Nakasa.
Anton, Mr. Onaka, Pak Yamin.
Pak Wiluyo, makasih.
Makasih. All. Ya,
Thank
thank
you.
you.
Ya,
Bye.
Pak Antonio, siapa?
Ya,
Thank you,
sama-sama.
Pak.
Makasih,
Kara.
Pak. Makasih, Pak Gun.
Pak Trisno.
Makasih, Pak.
Terima kasih Bapak-Bapak semua, Mr. Park Ho Yung Ho, Mr. Akira Onaka, thank you so much.
Makasih, Pak Ken.
Bye. Bye.
Thank you.
Bye.
기원전 27년
27 years BC. The building called Pantheon Synagogue that has been built by the Emperor Agrippa of Roman Empire is one of the oldest construction buildings that were built during the Roman Empire era. The ceiling roof opening in the Pantheon allows the natural sunshine to come through and to shine the inside of the dome. In order to effectuate the beautiful occurrence, the height of the ceiling has to be elevated 42 meters. One of the main reasons that the ceiling of the Pantheon Synagogue dome ceiling does not have cave-in is because of using special construction material, lightweight aggregate that is lighter than the regular rocks. This time, we'd like to introduce you the principle of the light construction material that can float underwater called lightweight aggregate. There are lots of pores. We can control the density of the lightweight aggregates, and it can be heavy and light as we want. We control the size of the pores inside the aggregate so that it can be served as a construction material that will possess various characteristics. Well, let's take a look at the house and compare the ones built by domestic artificial lightweight aggregates and natural ones. In order to find the difference, we have taken a sample concrete of one made with the natural and one made with the artificial aggregates. The one on the left one is a natural rock. The one on the right is the concrete that are made with the artificial lightweight aggregates. First, we decide to compare the hardness of the two. We put two into press machine and insert the pressure, and as the time passes, both of them started to break apart. Although the result shows that concrete comprised of the regular rock is a little harder, the result shows that both can be used in structural construction building. But when it comes to heat insulation, soundproof, and density, artificial lightweight was much superior. If constructed by the artificial lightweight aggregates, because of the pores in the artificial lightweight aggregates, the density of the concrete becomes low, and the pores inside the aggregates decreases the flow of the energy transfer. Because of this, the sound transfer energy and heat transfer energy are lessened. The coal-fired power plant in Yeonghung Island near Seoul, domestic-made ingredients for artificial lightweight aggregates are produced right at this location. In order to generate the electricity when the coal are used, fly ash can be used in part of material for cement, and bottom ash, which now is impossible to recycle, and being thrown into the ash pond situated adjacent to the power plant. As of 2009, annually, 8.5 million tons of coal ash has been produced, and out of that, 3.1 million tons is being thrown into ash pond. Waste treatment cost for the ash per year comes out to be $50 million per year, but bigger problem is that the lifespan of the ash pond will be dissipated after 3 years. Furthermore, annually the natural aggregates are being procured 200 million cubic tons per year. In April 6, a new factory was erected next to Yeonghung coal-fired power plant. It is the factory that utilizes the coal ash, especially the bottom ash, to make artificial lightweight aggregates. By making artificial lightweight aggregates, it not only enhances the preservation of the natural environment and also reduce waste treatment costs, also it creates more jobs. It is like killing 3 birds with 1 stone.